next topic is theorem 4. Okay, so we're going to theorem 1, theorem 2, theorem 3, theorem 4. Please make sure you understand, okay, all the theorems. Like understand one theorem before you move to the next. Or else, if in case we are solving the tutorial questions or doing the tutorial session and we are solving other questions, you may be confused, okay? So kindly make sure you understand them perfectly. Okay, so theorem 4. It states that the sum of opposite angles of a cyclic quadrilateral is always 180 degrees. So the keywords opposite angles and then cyclic quadrilateral. So a cyclic quadrilateral is just a quadrilateral or a figure, a four-sided figure that is inscribed in a circle. Okay, so if this is a circle, okay, and I have a polygon, and I have a quadrilateral, okay, inscribed in a circle. So this is a cyclic quadrilateral, but something like this is not a cyclic quadrilateral. So please note. So we are talking about quadrilaterals that are inscribed, okay, that are inscribed in a circle. So this is not complete, so kindly ignore that. Okay, so we are saying that the sum of the opposite angles. So another keyword here. So opposite angles. So angles that are directly opposite. So this angle is opposite to that angle. That angle is opposite to that angle. So please note that we're talking about this angle. So let me make this angle A. So let's say we have a cyclic quadrilateral, say A, B, C, D. We are saying that the angle here. So this is B degrees, this is C degrees, this is A degrees, this is D. So you're saying that B plus D, the sum of the opposite angle, must be equal to 180. So you're saying that A degree plus C degree is equal to 180 degrees, and then B degree plus D degree is equal to 180 degrees. So that's all that the law is saying. That was why I said that if in case here is 110 degrees, then obviously D will be 70 degrees, provided it's a cyclic quadrilateral. As simple as that. So we are going to look at a question under this. Okay, so let's say you have a circle here. And we have a cyclic quadrilateral. Okay, and this is say 30 degrees, and you're supposed to find, say, x. You just say that x plus, for a cyclic quadrilateral, the sum of the opposite angles is 180 degrees. So therefore, x plus 30 degrees must be equal to 180 degrees. What then is x? X is just 180 degrees minus 30 degrees, and that's just 150 degrees. That's the final answer. So as simple as that. So let's look for a more difficult question, and that is, so we have a diagram, okay, like so this is not drawn to scale, and we have B, C. So we already know that this is a chord, okay. So sorry, supposed to meet. Okay, so this is A, B, C, and obviously this one will be D, and it has, so that means this. Okay, let me finish with a drawing. So when you're giving a diagram, you have to make sure you understand, okay, every bit of There you go. So the question goes like this: in figure blah blah blah, A B C D are points on a circle, and they give. So you have to know this. They say that AB is equal to AC. So line AB is equal to line AC. That's demarcated by these lines, and then angle BDC is equal to 50 degrees, and angle ABD is equal to 30 degrees. Calculate or find angle CAD. So you're supposed to look for angle CAD. Where is angle CAD? So this is angle CAD. So I'll start by a solution. Sometimes you'll be given the word problem, so you have to draw, like, represent the question in a diagrammatic form. But here in this case, you are given the diagram. Okay. So solution. I'll just say that let angle CAD be equal to x degrees. Okay. So I'll start by writing the values. We know that this angle, you're supposed to find angle you're supposed to find angle CAD. Okay. So supposed to be CAD. So this is the angle you are looking for. So let this angle be, say, A. So let's be angle CAD be 8 degrees. Okay. Yeah. So let the x remain, because it's important. Now we know from the rules of the theorem, the first theorem, that I think the second I forgot, but it doesn't matter. The angles subtended by this chord at the circumference, they are the same, the angle. So x is equal to 50 degrees. Okay. By inference, x is equal to 50 degrees. So I'll just write 50 degrees here instead of x. X is equal to 50 degrees. Okay, good. Now, what then can we say? This is a triangle. This is a triangle, that's also a triangle. Okay, so what else can we say? This is an isosceles triangle. They just said it because AB is equal to AC. So now if this is an isosceles triangle, then I can say that this angle, okay, is equal to that angle. So let those angles be, say, B degrees, B degrees. Okay, so therefore I can say that 50 degrees plus B plus B should be equal to 180. Okay, so 2B is equal to 180 minus 50. Okay, and this will be 130. So B will be equal to 130 out of 2, and that is 65 degrees. Okay, so that is 65 degrees. So here is 65. All this angle has 65 degrees, and this also 65 degrees. So if there's 65 degrees, then this all will be 35 degrees. Okay, because this whole angle is 65 and that is 30, so this will be 35 degrees. So you can just say that angle CBD, okay, angle CBD is equal to 65 minus 30 degrees, and that is equal to 35 degrees. Okay, and supposed to, but the question was asking for angle CAD. Okay, so we are looking for angle CAD. Okay, we are looking for angle CAD, but we know that this angle CAD, okay, angle CAD is is subtended by this chord. This chord is CD. Okay, we are using the laws here. This is not different from what we've done. So CD is also a chord, and this chord is subtending an angle at this point of the circumference A, and also subtending an angle at the circumference B. But we've already looked at theorem. That's also the first theorem. The first theorem. No, that was the second theorem. You've seen from the second theorem that the angles a chord subtends at the circumference in the same segment of a circle are equal. So they are in this same segment. This is a minor segment, this is a major segment. So therefore, you can say that A is equal to 35. Okay, so you can say that angle CAD, okay, is equal to angle CBD, and that is equal to 35 degrees. Simple as that. Okay, that's it. Okay, angle CAD is equal to angle CBD. Okay, this angle is equal to that angle. That's 35. Thank you very much.